this task centers around the plum pudding model and the changing views of our of the atom. So what's the difference between carbon 12 and carbon 13? Carbon 13 has 7 neutrons, and carbon 12, both notations here, has 6. So that's the difference. There's a different number of neutrons. What's the word we use to describe atoms? These are isotopes. Okay, isotopes, very big, important word. Although quite a bit more important in physics than it is in chemistry. Describe the plum pudding model. It was Thomson. Plum pudding model. And you have a positive substrate with negative particles dotted throughout. Okay, essentially one big lump of positive material, and you have tiny little plums of negative dotted throughout. So it's like still one solid big object. Okay, nuclear model that we use today. We've got a nucleus that has positives and neutrons, and we've got negative particles along the outside. That's electrons. That's a shell. That's the nucleus. And you've got protons and neutrons. Describe how the gold foil experiment was carried out. Well, essentially Rutherford fired alpha particles. These are massive positive particles at very thin gold. Very thin gold foil, and observed scattering. Basically, things deflected all over the place. Most of the stuff passed right through, but some of it did deflect, and that was not what he expected to see. Most of the particles went straight through the foil because the nucleus is tiny. Tiny. So atoms are mostly empty. Some particles were deflected significantly because the nucleus is very positive. Okay, so that reflected the positive alpha particles, and I am recording. Whoops. Okay. Keywords, plum pudding model, there. Rutherford, I spelled Thomson wrong. Rutherford did the gold foil experiment. Shells, protons, neutrons, isotopes, all defined here. J.J. Thomson did the plum pudding model. Alpha particles, gold foil experiment, that's here, number 4. Nucleus, here, very important to all this. And electrons being very, very, very tiny negatives. All right.